This is a great slide presentation to introduce us to prefabricated modular construction. So this looks like it was part of a workshop where they tried to involve people in looking at massing models for modular construction. And I'm going to step through it relatively quickly, only to with the idea that you're going to come back, download this. You have the hyperlink from from the slideshow, and take some time to look at this. They introduce us to the idea of modular construction. Obviously, this is for people who have no, maybe almost no architectural experience. The idea of it going up, this is, you see the weather protected modules, notice the crane, the hoisting rigging up here, and then the finished look of that project. Obviously, what's going to happen is we're going to, why modular? They talk about faster schedule. That could be or could not be significant on a project depending on where it's being built. But there is this idea that by using modular components, we can have a shorter lead time to the completion of our project. Cheaper labor, work done in factories, less time doing the work because it's more regulated. More control over the labor source. But there are also negatives with this idea of cheaper labor. Do we have control over the exploitation of labor? Is there equitable work standards? I think higher quality is one that we can really hold up to a test. Typically, things that are built in the factory to specifications can be quality assured more easily. There's more traceability of componentry. A lot of things happen when we look at, manufacturing in a factory environment, and the idea of less exposure to weather. But at the same time, building construction methods are really quite sophisticated. The idea of things that happen with exposure to weather are in many cases well controlled on modern construction sites. Worker safety, another issue. Once again, the idea of falls and things in systems that we have no control over, or environments that we have no control over. But the flip side to that worker safety is the idea that we may not have control over the workplace of remote locations where modules are being made. And as we saw, we looked at modules being made in Poland and shipped to the United States. So there could be places where our buildings are constructed where worker safety is not a paramount. And when we talk about safety, it's not just physical hazards, it's environmental hazards, it's working hours, it's standard of living, quality types of things. Less material waste, I think, is a great possibility. Factories could have much better control over recycling and control of the amount of materials, especially since all of their unit cuts have a certain consistency to them. And then they go on to talk about less environmental disturbance. These get to me a little more harder to pin down. So the idea of why not modular, what are the problems with it? One of them is this idea that we can't build as tall. We have over-the-road limitations for shipping things, typically 8 foot 6 inches wide. So we have the floor-to-floor height is different as compared with conventional construction methods. In residential construction, this might not be significant, but there's always this idea that we have we're creating grander and grander residential units. These are typically high-end constructions in many cases. So the ceiling height might be a real limitation to the perception of quality of what's being built. And there's no reason why these couldn't be higher. They just come with them new constraints about shipping and transport, and therefore transfer to cost. This idea of labor rates for locations about where things are being built. As they say, certain places it may not make sense because labor rates and the union relationships are disruptive. I don't want to spend too much time on cost. I don't think that's really where we want to go with our advanced structures look at things. But obviously this may be your only touch with looking at the overview of modular construction. The market perception of modular. I think this is changing. This image over here, actually, I find quite intriguing. But modular construction today, I think, is relatively a respected way of thinking about constructing, especially when we look at this idea of custom-built homes and modular. There's a lot of publications now about the quality of modular construction for single-family residence, high-end residential construction. And in this case, I think that there's actually a flip of the cost. Modular construction, I think, in many ways can be more expensive than site-built because of the one-off nature of the construction. Who's on site, the coordination of contractors and skills can usually drive up complexities over conventional custom-built homes. Obviously, this is the far-off kind of idea of what modular can be in these beach structures. A little more onto what we might see as thesis projects or other things, emergency structures, emergency housing systems. These became really significant when we looked at what China was doing during the inception of the pandemic and building a quickly modular hospital system. This is an interesting one because of the idea of the modules not looking like modulars because there's an overlayer of the facade. And here we have just condominiums. They're showing us some building types. This is shop architects. I think this is unique because of what they've done to articulate. They're not hiding the modules. They're just articulating the modules with unique elements, something that we kind of pay attention to in our project. So they go on to a lot about play with architecture. I think one of the things to, I guess, be forewarned about is once you start moving these modules back and forth like this, you have to concern yourself with load paths. But in many ways, these modules can all be the same basic structural depth, and have these extensions that don't drive the load path, don't have to accept the load path down. And what I'm saying by that is they can be balconies or things that are cantilevered over the front edge of the module. But so we have this idea of these expression of module systems and then different kinds of unit configurations. And this one is what I was talking about before. You have modular construction, but you've done a final facade that encloses those modules, so to disguise the modular elements that build up a full facade. And here we have moving these facade elements back and forth. Really beautiful new articulations of shapes we'll see here, but a huge paradigm shift to the idea of cost. Now we have really significant issues, and I don't even know if these are all modular constructions or just designed to look like them, but we have really complicated load paths to pull through here that all of a sudden make it look like steel frame stick-built construction might be a better way to go in this type of module. But there are obviously places where these modules can be well predicted as far as the way load paths are transferred through, because each element repeats on itself in a similar way. So I'm not totally discouraging that idea, but I'm just throwing up a warning flag because here we come up with some really, well, in this case, once again, looks like it's not really doing much twisting, so there's not much transfer of load path. It's just really about, well, the more I look at it, I see these really large cantilevers over these. So we're really pulling load paths back all along this front facade, which means that the steel in here in each module is going to need to be somewhat different. So really quite complicated. I think they did a lot of this because they had blocks and then they found associated projects that went with it. So I think we can be a lot more successful with beautiful architecture, but a lot less tame in our massing systems. So they just compare wood structures, and so we have and steel structures. Talk about modular dimensions that work. in wood frame like this, we're talking 3 or 4 stories. We know that we have modular construction systems that exceed that in heavy timber. Your steel framing, I think we can think about this very similar to the way we think about mass timber construction. And it's just comparisons between those two. I think it's nice to point out, to pay some attention to these. Look at this idea of the double wall between the units, and see this is both advantages and disadvantages. Obviously, a duplication of the construction systems, but we need to include these kind of double layers of plasterboard, air brakes to control sound. So in many cases, I'm not. This duplication of surfaces from one unit to the other is not necessarily a negative and or a significant cost increase in our construction systems. We'll notice down here the diagonal bracing to create stiff assemblies in steel, and then allow for openings between modules, because obviously one module placed to the next one allows for the double width of a unit. And some steel details. Permits and inspections. Obviously, the big flag that comes up here is we're having a module made in a municipality that may not be the one where the building's constructed, and the coordination between 2 municipalities about where certain parts of the construction are inspected, what approvals are met, and whether those are accepted by the final destination of the building. So obviously, this is really a very complicated issue that needs to be addressed very early in any kind of conceptualization of modular construction. Typically, it would start probably with the modular building manufacturer, who has already established relationships, finding out if they do already, in fact, work with other municipalities, especially the one that you're considering, and laying the groundwork for that. And then the idea of actually finding that manufacturer and its relationship to your project, and whether that's actually feasible. There is the possibility you conceive modular in a place that's so remote from where modular construction is happening that just makes it a quick non-option. Just some shots of factory work. Transportation, once again, that idea of the width of the module. If it's 8 foot 6 inches wide, it can go over the road without any special considerations. Once it breaks that, it becomes an oversized load, and transportation becomes a lot more significant, the cost involved with that. Foundation systems. Obviously, we've already discussed this idea of a soft story, that we're supporting multi-story buildings above what is called the podium. And typically those podiums are constructed of concrete. They could be constructed of other materials, but the idea here is that we have to be strongly cognizant of not creating a soft story for seismic reasons. So we need to have concrete typically lends itself to making a very rigid concrete reinforced moment frames and shear wall assemblies. So it's usually a choice for the first floor podium construction. Here we have modules going into place. This is a great graphic about whether it's feasible to actually even erect a modular building on a specific site in a dense urban location. So here we have a crane on site. The idea that it has the capacity to lift the modules. These are some methods of lifting, how they would attach the module. These would be coordinated between really at the modular factory. But this is the operational limit of that crane. I'm not sure this is set at 75 tons, but the idea that it could pick 75 tons up at 152 feet out or whatever, 157, and then work within this volumetric envelope to move that module. And then, so this is an elevation view, and in plan view we have that crane. We have trucks coming in delivering modules, actually lifting and swinging over an existing building to the site. And then this idea of being able to move these modules in a staged way. Which one goes first? Like in this case, it looks like they need to make clearance to come back in and place those modules. So These could be, in certain sites, the deal killer on whether it's practical to do modular construction. Some nice illustrations of connection systems. The idea of this is sometimes referred to as a PEM fastener. The idea that you can blindly fasten two things together. You can put a screw through one side and then have it, how can I say it? You don't have to hold a nut on the other side in order to bring them together. In this case, it's riveted together. These are nice images of that idea of what happens when these metal parts come together, and then how are they connected to become continuous, load paths. Once again, that idea of wall cladding. We have modules put in place, but the wall cladding systems are added afterwards in order to actually can be used to mask that idea of individual modules. This is kind of a neat idea of prefabricating even the vertical circulation systems into modules, even elevator shafts in specific modules. We really need to concern ourselves with the idea of mechanical plumbing systems, these risers that go up in multiple story buildings. So in this case, the modules have a little notch in them that allows a cavity between them to be created to run those utilities up between the units. So they could be part of each unit or just part of one unit. So here you can see it, a unit here and a unit there, and then the ability to put an access door there to do the hookups as the modules are built. The promise of really nice interior finishes in factory-built construction systems. And in this case, this is just a run-through of a site to do a little bit of cost analysis and and feasibility analysis. Once again, the steel modular units over the concrete podium. I find this to be strikingly similar to what we'll do later on in this semester with TestFit, which is a generative design program. Well, it's probably overreaching to call it generative design. It is a parametric assistive device to help us do these kind of layouts, and does this automatically for us. Unit design. I guess one of the things to pay attention here is the requirement of 11 foot 6 inches for something like a bedroom, and how if we're working on an 8 foot over the road module, we need to be able to join two modules together in order to create these kind of large spaces. So there may be limitations. There may be actually desirable limitations in your modular concepts because unit sizes are going down. We're much more in large urban areas thinking about micro units and mini apartment units, compact, to increase density and reduce unit rental cost. Once again, a lot of this is really becoming automated. There are many pieces of software now that are helping us or assisting us in doing some of these layouts. And then this is going to finish off with cost analysis. And you can see that so the idea of in a union job, just the penny savings, so to speak, of modular construction, maybe more significantly the opportunity for some time savings. And this time savings may directly relate to money, especially in places like Manhattan, where disruption is a huge cost premium to it. But there are other places where the length of time to finish may not actually be a significant factor in the project. And then they get into really deep project return cost analysis. And that's it.